Okay, so just to remind you where we're at, we are in Chapter 9, and we're talking about power series. But to get to power series, we're actually doing polynomial approximations. And so let's go ahead and look at the example we've been focusing on here, because we're going to do some more with this example here, just so that we can maybe see a pattern that's emerging here. So remember, what we're looking at is we have f of x is equal to the square root of x, and we've said that a is equal to 4. And what we've been doing here is we've been doing a linear approximation and then a quadratic approximation. Now remember here, I'm just going to put here, I'm going to say, what do I want to call these? I'm just going to call this L1, because these are approximations. And L1 is going to be equal to, well, it was 2 plus 1/4 times x minus 4. This was my linear approximation. Alright, so that was my linear approximation. And we had the quadratic, which I'll write as L2, which is equal to 2 plus 1/4 x minus 4. And then I believe, if I'm remembering correctly, it's 1 over 32 minus 1 over 32 x to the minus 4 squared. And we're going to go ahead and double check that negative 1 over 32 just to be safe. So now what we're going to look at is, okay, we said that quadratic gives me a better approximation, but we want even better now. We want to get a cubic approximation. And so what we're going to need to do is we're going to need to add on another term, c, times x minus 3, not x minus 3, x minus 4 to the third power, because that will give me a cubic. But then again, we have to determine this. And then, just to remind you, we wrote it up on the board a different way, but, you know, L1 at A equals f at A. Actually, I'm going to go to L2 here. L1 at A does equal f at A, but for L2, remember we had L2 at A equals f at A. Then we also had L2 prime at A equaled f prime at A. So we're going to be doing an L3 here, cubic approximation, but we can think what we're going to do is we're going to want to have the third derivative. Sorry, I messed this up here. The first derivatives for L2 come matched, and then the second derivatives also matched. But then if we're going to put on this third term, we want the third derivatives to match. Okay, so let's just start maybe coming up with a systematic way of doing this here. So we're going to have f at x is equal to x to the 1/2 power. F prime at x is 1/2 x to the negative 1/2. F double prime at x is negative 1/4 x to the negative 3/2. F triple prime at x is, well, let's see if arithmetic doesn't fail me now. 3/8, 3/2 times 1/4 is 3/8, and of course the negatives cancel each other. X to the negative 5/2. And I'm going to go ahead and do one more, because even though we're doing a cubic, we're going to see if we can just write down the quadratic one here, or the quartic. So F4, now remember, when you get to higher order derivatives, what we do here is we put it in parentheses. So this is not an exponent because the 4 here is in parentheses. This is referring to the fourth derivative. And this would be negative 15 over 16 x to the negative 7 halves. Now, what I'm going to need for each of these is I'm going to evaluate f at a for all of these. I'm going to evaluate all of these plugging in a. So f at a, of course, is just, it's 4, so this is just equal to the square root of 4, which is 2. F prime at 4, well, that's 1/2 times 4 to the negative 1/2, which is 1/4. F double prime at 4 is equal to sorry, I'm just lost my train of thought there. Negative 1/4 times 4 to the negative 3/2, which is negative 1 over 32. F triple prime at 4 would be, what do we have here? 3/8 x to the negative 5/2. Not 5, x would be 4 to the negative 5/2, which I'm just going to do this real quickly on my calculator because my brain is not functioning at full capacity right now. And we actually get 3 over 256. And then the fourth derivative, evaluated at 4, would equal negative 15 over 16, 4 to the negative 7/2 power, which give me a second to punch this into my calculator. And we get negative 15 over 2048. Okay, so let's go ahead and write down, and I'm going to do L3 here because it's going to be a cubic. We know that L3 is going to be, well, we have the 2 plus 1/4 times just a second. Okay, we're okay here. I just forgot. I paused it here. I just actually had a mistake up here. I believe this is not 1 over 32. This is 1 over 64. But we're going to verify all of these here just by going through this example in much more detail. So instead of doing L3, let's do L1, x minus 4. So that's my linear approximation for L1. So L2, we're just going to go through this all again like we did it. This was going to be 2 plus 1/4 x minus 4 plus, and I'm going to write this as C2 because it's the constant dealing with the second derivative, times x minus 4 squared. And so if I look here, L2 prime at x is 1/4 plus 2c2 x minus 4. And so L2 double prime at x is equal to 2c2. And remember, we wanted these derivatives to match. So we know that we want L2 double prime at x to be equal to f2 double prime at x. So we know then that negative 1 over 32 has to equal 2 C2, which gives me C2 equals negative 1 over 64. But I'm actually going to purposely write this as negative 1 over 2 times 32. I'm going to do that, and you'll see why, because we're trying to come up with a pattern here. So L2 double prime is going to equal 2 plus 1/4 x minus 4 minus 1 over 2 times 32 x minus 4 squared. Now we said, what are we wanting to do? We're wanting to add on the third derivative here. So we have L3 at x is going to be equal to, well, it's going to already have the same terms as what I've already got. And I know it's 64, but again, I'm purposely leaving that as 2. And I'll put on a C3 here. This should be squared. And then this is cubed. And we know we want L3 triple prime at A equaling F triple prime at A, which F triple prime at A is 3 over 256. Okay, so I actually need to take the third derivative here, but the good news is you already have the second derivative here, L2 double prime. The second derivative for L3 is going to be this plus this additional, let me circle here. L3 second derivative is going to be the same thing here with this added term on. So let's go ahead and do those derivatives. So L3 prime, is equal to 1/4 minus 1 over 32 x minus 4 plus 3c3 x minus 4 squared. L3 double prime is then negative 1 over 32 plus 3 times 2 C3 x minus 4. And then finally, L3 triple prime is equal to 3 times 2 C3. And so we know that we want this triple prime to be 300 over 256. So we have 3 over 256 is equal to 3 times 2 C3. So C3 is going to be, and I know this could simplify out, but I'm not going to do this, 3 times 2 times 256. Alright, so let's write down this L3 here. And I know this seems like this is going to be really complicated and confusing, but we're really just looking at this example to see if we can discover a pattern to make this much simpler, which is what we are going to be doing. So L3 here, we have that this is 2 plus 1/4 x minus 4 minus 1 over 2 times 32 x minus 4 squared, and then it's going to be plus 3 over 3 times 2 times 256. Times x minus 4 cubed. Now let's go ahead and start looking at what we have here. Let's look at this term here and split it apart a bit. So I'm going to write this as 1 over 3 times 2 times 3 over 256. And I'm going to stare at this for a second. I'm going to say, wait a minute. What if I did 3 times 2 times 1? Have I changed anything? Hopefully you all agree we haven't. But what did we notice here? Well, wait. 3 times 2 times 1, this is actually 1 over 3 factorial. And then what is this term here? Well, that was just simply f triple prime evaluated at a. Well, that's interesting. Let's see if that pattern holds. So let's look at this one here. So I'm going to write it as I'm going to write this as 1 over 2 times negative 1 over 32. Well, I could write this as 2 times 1, and then wait a minute, yeah, I could write this as 1 over 2 factorial times the second derivative evaluated at a. Well, let's see if it holds for this term. Well, I have 1/4. But wait a minute, that's just simply f prime at a. Well, where's my factorial? Well, it's easy. Just add in 1 over 1. You know, 1 over 1, I don't know why I circled that bottom one. Doesn't change anything, but we could still say, yeah, this is 1 over 1 factorial, and it's still the same. Well, there's one other one that we need to check. This 2 here. Well, okay, what is this 2? Well, there's no derivatives. So this looks a little weird when we say this, but you can write this, and we call this the zero derivative. And the zero derivative is simply equal to f at x. But if we continue the pattern here, I would need to, because I go 3, 2, 1, I'd have to have 1 over 0 factorial times f at a. But we should remember that 0 factorial is something we can do, and this is simply just 1 over 1 times f at a. Now, what can we do here? Well, we've seen a pattern. Let's look at L3, my approximation for L3 now, using some of these terms. So this would be 1 over 1 factorial times f at a. And then we have plus f prime at a over 2 factorial times x minus 4 squared. Or, I'm sorry, not squared, this is the linear term to the first power. Then we have plus f double prime, mixed up here, f prime at a times x minus 4 over 1. Let's erase this all here. Sorry about that. My words got all confused. Let's start over here. So we're trying to write L3 at x. So let me even just scroll up here. Maybe. There we go. So we need to write this term here, which if I go to my arrow is 1 over 0 factorial times f at a. Plus, and then I get 1 over 1 factorial times f prime at a. Oops. Times x minus 4. And then continuing, we get plus 1 over 2 factorial f double prime at a, x minus 4 squared. And apparently I was writing too big, so I'm going to have to write this down a little bit here. Plus 1 over 3 factorial f double prime at a, f triple prime at a times x minus 4 squared. Now, let's look at some patterns here. We almost have everything here, but notice we have an x minus 4 in each of these cases except for this first one. There's no x minus 4 here, but you can add it in. And it seems a little silly to do it, but then we can get a very good pattern. 1 over 0 factorial times f at a, x minus 4 to the 0 power. Because that would make sense. Actually, this should be a cubed. Because what's my pattern here? Cubed, squared, 1. Well, the next one would be 0. And of course, if I do x minus 4 to the 0 power, you just get 1. So that is the same thing there. Now, following this pattern, and I know this video is getting a little long, but we're almost done with this. Following this pattern, L4 at x would simply be L3 at x. Let's see if we can guess. It would be f fourth derivative over 4 factorial x minus 4 to the 4th power. And then we could even do another one. L5 would be L4, and then I'd just have to add an additional term. This should be evaluated at a. 5th derivative evaluated at a over 5 factorial x minus 4 to the 5th power. Now, powers, these are polynomial approximations, so we're only going to go like maybe n equals 4 or 5. A power series is basically the same idea, except instead of doing only like a quartic or a quintic approximation, we're going to do this as you go to infinity. We're going to let the polynomial get as many terms in it as we want. But we're going to do another example with this in the next video.